Today we'll see different type of relations. So with the use of these sets and the values that are available in the sets, what are the different relations that we can form and how these relations will be used in computer science and whatever the subjects you study in future, that and all we'll see in this lecture. Different type of relations. So here 6 properties of relations are, so we are going to mainly focus on these 6 relations: reflexive, irreflexive, symmetric, asymmetric, antisymmetric, and transitive. Antisymmetric and transitive. These are the very basic relations that you have studied in your school level or maybe +1 or +2. However, knowingly or unknowingly you have studied that. When we are discussing these concepts, we'll see what are the application areas in which you can use these relations. First of all, the reflexive or irreflexive. A relation R on a set A is called reflexive if A comma A belongs to R for every element A, that is small a, which is the element which belongs to the set capital A. Are the following relations on 1, 2, 3, 4 are reflexive? So here are some relations given. R is equal to 1 comma 1, 1 comma 2, 2 comma 3, 3 comma 3, and 4 comma 4. According to the definition, the reflexive means the first order element and the second order element should be same. So that is the reason here it is not, this particular relation is not reflexive. And the second relation 1 comma 1, 2 comma 2, 2 comma 3, 3 comma 3, and 4 comma 4. Is it reflexive? So consider the following relations on 1, 2, 3, 4. So here are the relations. Now here is the question: which of these relations are reflexive? So without looking at the solution, identify what are the relations that are related to. Okay, the relations R3 and R5 are reflexive because they both contain all pairs of forms A comma A, namely 1 comma 1, 2 comma 2, 3 comma 3, and 4 comma 4. The other relations are not reflexive because they do not contain all these ordered pairs. In particular, R1, R2, R4, R6 are not reflexive. Now try to solve the considered relations that we have seen in the last lecture. Total 6 relations we have seen, observed. By considering those relations, which of these relations are reflexive? R4, R3. Here R option is there, not AND option. R is there, either it may present or may not present. So R3 and R4, R1 can also be, because it is also less than or equal to. Okay, but based upon the available set 1, 2, 3, 4, so there are no negative elements, and A less than B is possible there. A less than B possible there, and A is equal to B also possible. So in such a cases, when A less than B is possible there, so it is better to avoid. When A is equal to minus B is there, anyhow there is no negative elements. When you consider that 1, 2, 3, 4. So obviously you can consider R3 and R4. So next one is symmetric, antisymmetric, and asymmetric. So these are the properties in which we'll see the symmetric and asymmetric, where we popularly use in our computer science. Because if you want to represent the algorithm in a paper, in a research paper or in any document, you cannot completely write the algorithm. Instead, you represent it in mathematical terms. So in order to use it in mathematical terms, so whenever you use in mathematical terms, obviously it is a universal language, anyone can understand. Otherwise, if you write in a plain text or in your own words, so obviously the natural languages are ambiguous. So the reading or the particular understanding will be different from person to person. So a relation R on a set A is called symmetric if B comma A belongs to R, whenever A comma B belongs to same relation R, for all A comma B belongs to A. A relation R on a set A is called antisymmetric if A is equal to B whenever A comma B belongs to capital R and B comma A belongs to capital R. And while coming to the asymmetric, a relation R on a set A is called asymmetric if A comma B belongs to R, implies that same key should not be used. So B comma A is not belongs to R. Okay. So here different key must be used. Asymmetric means different way. So for all A comma B belongs to A. Now what you do is you make a simply a table mentioning 1, 2, 3 on the top column and on the rows 1, 2, 3. Just to make a pairs, make the pairs 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. So make a table. On top of the table 1, 2, 3. At the rows 1, 2, 3. Make the pairs like a matrix. 1, 1, 1, 2, 2, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. Now what the antisymmetric is telling you that it will allow you the diagonal elements. 1, 1, 2, 2, 3, 3 can be allowed. Okay, 1, 1, 2, 2, 3, 3 can be allowed. And in the same relation, if 1 comma 2 is there, then there should not be 2 comma 1. If 1 comma 2 is there, okay, it's accepted. But in the same relation, 2 comma 1 is there, then it is not antisymmetric. So that means it will allow the diagonal elements. Okay, it will allow you the diagonal elements and lower diagonal and upper diagonal elements. Any element can be allowed, but the same opposite, that is opposite of the upper diagonal or lower diagonal, if it is present in the same relation, then it is not accepted. Clear? Now, 1 comma 1, 1 comma 2, 2 comma 1, 3 comma 3, 4 comma 4. It is symmetric in nature because 1 comma 2 is there and 2 comma 1 is also there. But if it is there in any set, then it is not antisymmetric because the lower diagonal element, which is 1 comma 2, upper diagonal element, and its opposite 2 comma 1 was present in the same relation. So hence it is not accepted. So it will accept this. Antisymmetric will accept the diagonal and the pair 1 comma 2, like it's not opposite. While coming to this R 1 comma 1, it is symmetric and also antisymmetric because the antisymmetric is diagonal element 1 comma 1, 1, 1, 2, 2, 3, 3, which is acceptable. Next one is 1, 3, 3, 2, 2, 1. This is not symmetric. It is clear. Now what are the other features? 1, 3, 3, 1 is there. 3 1 is not there. 3 comma 2, 2 comma 3 is there? No. 2 comma 1, 1 comma 2 is there? No. So it is antisymmetric and asymmetric. Okay? Antisymmetric and also asymmetric. Now 4 comma 4, 3 comma 3, 1 comma 4. Diagonal elements 4 comma 4, 3 comma 3. Accepted. 1 comma 4 is there is no 4 comma 1. So still it is accepted. Clear? So this is antisymmetric. Consider the relations on 1, 2, 3, 4, same relations R1 to R6. Which of these relations are symmetric or antisymmetric? So here R2 and R3 are symmetric. Each A comma B, B comma A in relation. In R2, 1 comma 1, 1 comma 2 is there, 2 comma 1 is there. This is not antisymmetric because 1 comma 2 is there and its reverse 2 comma 1 is also there after flipping. Okay, so this is symmetric. Next, and R3, 1 comma 1, 1 comma 2. Do we have 2 comma 1 in this? Okay, 2 comma 1 is there. 1 comma 4, 4 comma 1 is there. Yes, 4 comma 1 is there. 2 comma 2, 3 comma 3, 4 comma 4. So it is symmetric. But it is not antisymmetric because 1 comma 2, 2 comma 1 is there. Right? And also not asymmetric also. Are you ready now? While coming to the R4, R5 and R6 are all antisymmetric because no pair of elements A and B with A not equal to B such that A comma B and B comma A are both in the relation. So in R4 if you look at 2 comma 1, 1 comma 2 is there. So accept 2 comma 1 as it is. Do you find any 1 comma 2? No. Okay. And 3 comma 1 is there. Okay, 3 comma 1 is there. Do you find 1 comma 3 in that? Huh? Do you find 1 comma 3? No. Next is 3 comma 2. Do you find 2 comma 3 there? Do you find 4 comma 1? Do you find 1 comma 4? No. 4 comma 2. Do you find 2 comma 4? 4 comma 3. Do you find 3 comma 4? No. So it is antisymmetric. If I have written in the same R4, if I have written 3 comma 3, still it is antisymmetric, right? But if I write 3 comma 3 in the same R4, it is not asymmetric. It is not asymmetric, but it is antisymmetric. I hope you got it. That is the reason, see, there are many explanations in the slides. That is the reason I have given a simple example. Take a matrix. 1, 1, 2, 2, 3, 3, diagonal. 1, 2, 2, 1, 1, 2, 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2. Diagonal accepted. Lower diagonal accepted, upper diagonal accepted. But upper diagonal reverse should not be there, lower diagonal reverse should not be there in the same relation. Same, again, we'll come across the same relations. We'll come to the same relations. R1 to R6. Now, which of the relations are symmetric and which are the antisymmetric? So that you make note of this, you can practice at your hand. So here, anyhow, answer was given. The relations R3, R4 and R6 are symmetric. R3 is symmetric if A is equal to B or A is equal to minus B. Then B is equal to A or B is equal to minus A. R4 is also symmetric because A is equal to B implies B is equal to A. Because A is equal to B means 1, 1, 2, 2, 3, 3. like that, because A is equal to B. R6 is symmetric because A plus B is less than 3, less than or equal to 3, implies B plus A is also less than or equal to, okay, 3. The reader should verify that none of the other relations is symmetric. So other pairs should not be symmetric. The relations R1 and R1, R2, R4 and R5 are antisymmetric. R1 is antisymmetric because the inequality is A less than or equal to B, and B less than or equal to implies that A is equal to B. So same diagonal values. Okay, 1 comma 3 is there, 2 comma 3 is there, 1 comma 4 is there, but not 4 comma 1 because A is less than B, right? This relation holds. So when this relation holds, obviously there is no reverse side. There will not be any reverse side of the relation. R2 is antisymmetric because it is possible that A greater than B and B greater than A. R4 is antisymmetric because two elements are related with respect to R4 if and only if they are equal. R5 is also antisymmetric because it is impossible that A is equal to B plus 1 and B is equal to A plus 1. So obviously always A is equal to B plus 1 means it is the second order pair value will be always greater than the first order pair. So there is no reverse possible. So final relation comes to the transitive. A relation R on a set A is called transitive if whenever A comma B belongs to R and B comma C belongs to R, then A comma C, okay, A comma C belongs to R. A is equal to B, B is equal to C means A is equal to C. If this relation holds, then it is said to be transitive relation. Okay, in databases you will get this. In filtering the data, when you are entering into the databases, the relation should not, the transitive relation should not hold, which will become the third normal form. Okay, that we will study in the databases. That is, if one field referring to the other field, and if that field, second field is referring to third field, then the first field should not refer to the third field. For example, your roll number signifies your student name, and if your name signifies your branch, then roll number should not signify some other things that you refer. So this kind of relation will be there, transitive relation. So we need to break up the transitive relation to have a perfect database design that we will study in the databases. This is called transitive relation, transitive dependency we can say. So transitive is nothing but A is equal to B is equal to C, then A is equal to C. So here 1 comma 1, 1 comma 2, 2 comma 2, 2 comma 1, 3 comma 3. So in which 1 comma 1 is fine, 1 comma 2, 2 comma 2. So next 2 comma 2, 2 comma 1, 3 comma 3. So here 1 comma 2 is okay, 1 comma 2, 2 comma 2. So here 1 comma 2 is there, 2 comma 2, 2 comma 1. So 2, 2, 2 comma 1. So 1 comma 2, 2 comma 1 is there, and 3 comma 3. So 1, 3, 3, 2, and 2, 1. So 1, 3, 3, 2. So if you remove this 1, 2, okay, do you find 1, 2 in this? A relation R on a set A is called transitive if whenever A comma B belongs to R, B comma C belongs to R, then A comma C should also belongs to R. Okay. 2 comma 4 and 4 comma 3. 2 comma 4, 4 comma 3, and 2 comma 4, 4 comma 1. The first pair and last pair. 2 comma 4, 4 comma 1. Do you find 2 comma 1 in the relation? So hence it is not transitive. We are not discussing about side by side pairs. This A comma B belongs to R, may be any pair of set that you find in the relation. Either it may be the first one or maybe last one, middle one. Then 2 comma 1 is present in the relation? No. So hence it is not transitive. Or it is not. So here are some relations, examples. So which one is transitive? The same again, 6 relations and find out what are the transitive relations.